Now, dear students, next topic, that is work. Now, work is a physical quantity which is defined as the product of the component of force in the direction of displacement and the magnitude of displacement, right? So this one is the definition of work done. Okay, now see here, suppose we have a block placed on the horizontal surface, right? And as shown in the figure, force F is applied on it in the direction making an angle theta with horizontal direction. And suppose under the effect of this particular force, this particular block is displaced by D. So here the component of the force in the direction of the displacement that we can write, that is F cos theta. Okay. Now, as per definition of work done, the product of component of force in the direction of displacement, so that is F cos theta, and magnitude of displacement, that is D. So we can write W, that is F cos theta into D, or you can write that is FD cos theta. Now, we already studied about the dot product of two vectors. Suppose we take vector A dot vector B, then that is AB cos theta. So similar to that, we can write this FD cos theta, that is vector F dot vector D, right? Now, unit of force, that is Newton, and unit of displacement, that is meter. So unit of work done, that is Newton into meter, and this particular unit Newton into meter, that is called joule, and its dimensional formula, that is M1 L2 T minus 2. Clear? Now let's discuss some special cases of work done. Suppose, see here, W, that is FD cos theta. In this theta, that is 0, it implies that if force and displacement both are in the same direction, then if theta is 0, cos theta, that is cos 0, that is 1. So W, that is F into D. Now if theta, that is equal to pi by 2, it implies that if force is perpendicular to the displacement, then in that particular case cos theta, that is cos pi by 2, and that is equal to 0. So work done, that is 0. Okay. Now here, if theta, that is pi, it implies that force and displacement are in mutually opposite direction. Then in that particular case, cos theta, that is cos pi, that is minus 1. So W, that is equal to minus F into D. So here, now in broad sense we can say, if theta is less than or equal, 0 is less than or equal to theta is less than pi by 2, if this condition is satisfied, then in that particular case the work done will be positive. Means if angle between force and displacement, that is either 0 or between 0 to pi by 2, then work done is positive. If work done is positive, then it is said work is done on the system. And if theta, that is between pi by 2 and pi or equal to pi, in that particular case your work done, that is negative, and it is said work is done by the system or body against the force. So this thing you have to remember carefully, because in MCQ or in any example, if it is given to you, the work done on the system, that is this much, then when you carry out the calculation, you have to take work done positive. And if it is given to you, work is done by the system, then you have to take that is negative. Then and there your answer will be perfect one. Clear to all of you?